Okay, so since many people regularly suggest that solar flares cause coronal mass ejections, could you briefly explain why the opposite is actually more plausible? Alright, let's just keep reading. That is, why do some of us believe the coronal plasma filament movement causes the X-ray emissions known as solar flares, not the flare causing the filament to eject? Well, let's address the first one firstly, right? So I'm not sure, like, why do many people suggest that flares cause CMEs? I mean, I can see the argument, but the thing is, there are flares without CMEs and there are CMEs without flares. So at least any significant ones. I guess it also kind of depends, it's a nomenclature issue. What do you call a flare? Because there's like an A and B and C class, which is like barely noticeable. But is this a flare or is this not? Because if you count A or B, I'm not sure if there's AA class actually, but if you count B class as flares, the sun is constantly flaring. It's pretty much like a continuous flare happening on the sun all the time, right? But if we're talking about like more strong events, at least like C8 or something, or M1 even, then still we have CMEs without flares, we have flares without CMEs. So my kind of conservative position is that these are just different phenomena. So one can occur without the other. They can coincide if there's like some really energetic, I don't know, motion happening on the sun, etc. And speaking of why do some of us believe that the coronal plasma filament movement causes the X-ray emissions, known as the solar flares, not the flare causing the filament to eject? I don't know. We gotta ask some of you because I don't suggest this, for example. So this is not a question for me specifically. Like yes, like when the filament is ejecting, there is a flare called Hyder flare, but it's not the usual in air quotes solar flare the way it looks, even on the X-ray plot. It's very long, very like uh, how do you call it, like smooth. It can last for many hours, whereas like the regular flare, like it happens well, roughly maybe 1 hour or something like that. Actually, depends again what you count as the duration of the flare in the first place. So yeah, or maybe even like whatever. You get the idea, hopefully. So yeah, there is a Hyder flare associated with the filament, but they are very rare compared to the flares in the active regions. So I don't know what exactly is implied here. This is not my position, and like whatever. I guess one can ask a question. Well, then what causes the flare? But that's a whole separate discussion. Like my understanding, and it's far from being complete because I haven't studied this in a lot of detail. I have studied it to some detail, to enough detail to understand that it would take years of research for me to, kind of grasp it. So we have the sun, right? This orange circle, and we have coronal loops. So we have one sunspot, let's say here, one sunspot here, and one sunspot here, and we have a coronal loop connecting them where there's a pretty strong electric current is running, and this is like kind of below the surface of the sun. We usually don't see it, but this thing is there anyways, but we don't see it. All right. But the magnetic field lines have to be closed. That's why I've drawn it like this as a circle. Let's just draw it with like a bit more, wonkiness. Like there's something below the surface of the sun, probably, supposedly, right? This is what we see above it. And there's a big current, as I've said. And I think what happens is, for some reason, this current gets disrupted at some point. All right? So it terminates at some point. But since this essentially magnetic coil has tremendous magnetic energy associated with it, but the current is disrupted, so this magnetic energy has to go somewhere. The current is no longer there, so it cannot stay in magnetic form, if you wish. So it gets released. It gets released mostly somewhere here at the point of the disruption, right? The whole energy of the circuit gets released there. This is what Alfvén initially thought, and I think it's a pretty interesting model to consider. Now, why exactly can the current be disrupted? Well, I have two ideas. For example, we can have, again, when most of the flares happen, at least according to, your everyday astronomer, is when you have multiple sunspots of different polarities intermixed, right? So what that allows to happen, I think, is that you have like kind of like many oppositely directed current loops nearby. So one of them can disrupt the other, and that kind of breaks the current. So if the current is counter-directed in them, right, the green one flows in one direction, the red in the other, and they meet, you know, like don't how do you call it, don't cross the streams, right? So the disruption happens, and the flare happens, so all this magnetic energy is released. So that's one possibility. And then, you know, you have the double layer forming where previously you've had current, and it accelerates the charged particles, and it also releases the energy in the form of photons, which we see and recognize as the flare, and all kinds of stuff like this is happening. Another idea I've had rests on the Weber's electrodynamics. So it's impossible in Maxwell's electrodynamics, but it is possible experimentally, all right? So I think it may hold water. So sometimes, if the current is very strong, I would claim you don't even need any opposite, any opposite sunspot kind of oppositely directed current. So just because the current itself is very strong, the magnetic repulsion from, let's say, this segment of the current and the next one, and they do repel in Weber's electrodynamics. They don't in Maxwell, but Maxwell is wrong because it has been demonstrated experimentally that this is the case. They do repel. So parts of this coronal loop may repel so much that the current would be disrupted once more, and this would produce the flare. So this would be kind of the second mechanism, but not really the mechanism, but like the second reason for the mechanism to, happen. And the mechanism is as Alfvén described it, right? So you have the disruption of the current, which releases the energy of the whole circuit at the place of the disruption, mostly, but not only. And obviously it can also release a CME, like it can energize the plasma around it and send it flying outwards. So this is my idea of how flares in general work. But I repeat, a lot of research is needed, but I think this makes sense, at least on some level. But then again, CMEs may happen even without it, but how do they happen without it? Well, that's a good question. Again, maybe something else is present, maybe it's not, I don't know. So I'm not sure about this. And the opposite is more plausible, that CMEs cause flares. This is definitely not more plausible, because there's many more, I would claim, flares without CMEs than there are CMEs without flares. That would be my point. Okay.